Hi, I am T. Kavitha, Assistant Professor, Department of Mathematics in Dr. S.N.S. Rajalakshmi College of Arts and Science. Today we have to see the topic of transportation problem. Solving method is northwest corner method. First we have to see in the what is transportation problem. A transportation problem is a specific type of linear programming problem. In this problem, we are tasked with the transporting goods from several sources to various destinations. The goal is to minimize the total cost of transportation, considering the supply and demand at the source and destination points respectively. Transportation problems can be of two types. First one is balanced transportation problem, the other one is unbalanced transportation problems. Balanced transportation problem is the supply and demand are equal. Unbalanced transportation problems, the supply and demand are not equal. To balance the problem, we might need to add a dummy row or dummy column. Here we find the solutions for two methods: initial feasible solution and optimal feasible solution. To find the initial feasible solution, we use the three methods: northwest corner method, least cost method, and Vogel's approximation method. In this video, we see northwest corner method. The following steps will guide you through the process of finding a feasible solution for a transportation problem using the northwest corner rule. Step 1. Start with the top left cell, the northwest corner cell of the transportation matrix. Assign it the minimum value of supply or demand, that is minimum of supply and demand. Step 2. Subtract the minimum value from the corresponding row and column supply and demand. This can result in three possible scenarios. If the supply is 0, cross out the row and move down to the next cell. If the demand is 0, cross out the column and move right to the next cell. If both supply and demand are 0, cross out both the row and column and move diagonally to the next cell. Step 3. Repeat the steps until all supply and demand values are 0. Here is the example for northwest corner method. So, get an initial basic feasible solution to the given transportation problem using the northwest corner rule. Here, demand and supply is given 11, 13, 17, 14. Solution: for the given transportation problem, total supply and total demand is equal to 950, 950. Therefore, the given transportation problem is balanced. Also, we can proceed with the northwest corner rule to find the initial basic feasible solution. Step 1. Consider the upper left corner cell which has the value 11. The minimum of the corresponding cell's supply and demand is 200. The difference between the corresponding cell's supply and demand from the minimum value obtained in the previous steps is supply is equal to demand. 250 minus 200 is equal to 50. Demand is equal to 200 minus 200, 0. As demand is 0, we need to allocate 200 to the cell and strike the corresponding column and then move right to the next cell. That is the cell with the value 13. For the cell with the value 13, the minimum demand and supply is minimum of 50, 225, then we get 50. Next, step 4, the difference between the corresponding cell supply and demand from the minimum value obtained in the previous step is supply 50 minus 50 is 0, demand 225 minus 50 is equal to 175. As the supply is 0, we need to allocate 50 to the cell and strike the corresponding column and then move down to the next cell. That is the cell with the value is 18. Next, step 5, for the cell with value 18, the minimum of supply and demand is minimum of 300 and 175. We get 175. Next, step 6, the difference between the corresponding cell supply and demand from the minimum value obtained in the previous step is supply is equal to 300 minus 175, that is 125. The demand 175 minus 175 is equal to 0. As demand 0, we need to allocate 175 to that cell and strike the corresponding column and then move right to the next cell, that is the cell with 14. Next, we should calculate the total minimum cost using the allocated values and the corresponding cell values. Here the transportation path is O1 to D1, O1 to D2, O2 to D2, O2 to D3, O3 to D3, O3 to D4. Therefore, the total cost is 200 into 11 plus 50 into 13, 175 into 18, 125 plus 4 into 14, 150 into 13, 250 into 10. Add all these products, then we get the value 12,200. This is the transportation cost value for this problem, 12,200. Thank you.